Welcome to Get Your FRQ On. This question is from 2013. It's question 2, and it is calculator active. In the question stem, we have a particle moving along a line. We have a function v of t that gives us the velocity of the particle at time t, and we know that the position of the particle at t equals 0 is 10. In part A of the question, we are asked to find any value of t between 2 and 4 such that the speed of the particle is 2. Speed of the particle is just going to be the absolute value of velocity. So we have this equation, absolute value of v of t has to equal 2. And given the v of t provided in the question stem, which is an unpleasant function, chances are you're not going to solve this one analytically. You're going to use your calculator for this. It is a calculator active question, so feel free to do so. If you want to graph this using your calculator, graph the absolute value of v of t, and then just graph a horizontal line, y is equal to 2, you can find that the points of intersection there are 3.128 and 3.473. So at those two times, which are both between 2 and 4, the speed of the particle would be 2. In part B of the question, we are asked to write an integral expression for the position function s of t and then use that to find the position of the function at t equals 5. So the integral expression would have to take into account the initial location of this particle, which at t equals 0 is 10. So the integral we would need for s of t is 10 plus the integral from 0 to t of vx dx. And again, this is a calculator active question, so we're going to use our calculator to calculate this integral for t equal 5. And it turns out that the position of the particle at t equals 5 is negative 9.207. In part C, we are asked to find all values of t between 0 and 5 when the particle changes direction and to provide justification. So the particle is going to change direction whenever its velocity is 0 and the velocity changes sign as well. Sometimes you have to watch out for a velocity function where v of t is equal to 0, but it doesn't change sign, so it doesn't change direction. In this case, we have v of t. Again, we're going to have to set it equal to 0 here, and that's going to be unpleasant to do by hand, so we're going to use our calculator to do this. Using our calculator to figure out when v of t is equal to 0, we get t equals 0.536 and 3.318, both of which are in the interval from 0 to 5. Now we have to analyze to see whether or not they change direction. If you look at the graph of v of t, which it's a calculator question, you should graph it. V of t does change sign from negative to positive at t equals 0.536. And it changes sign from positive to negative at t equals 3.318. So the particle is changing direction at both of those times. In part D of this question, we are asked if the speed of the particle is increasing or decreasing at t equals 4. To determine if the speed is increasing or decreasing, remember we have to have not necessarily values for v of t and a of t, the acceleration function or the derivative of v, at t equals 4, but we do have to know the signs and we have to compare those. So the speed of this particle will be increasing if v of 4 and v prime of 4 if they have the same sign, and it will be decreasing if they have opposite signs. So we need to figure out values for v of 4 and v prime of 4, or at least determine if they're positive or negative. So v of 4, it's a calculator active question, so plug 4 into this function in your calculator. V of 4 is negative 11.476. What's really important here is the fact that that is negative. And a of 4, or v prime of 4, is negative 22.296. And again, what's important here is that that is negative. So notice that v of 4 and a of 4 have the same sign, which allows us to conclude that at t equals 4, the speed of the particle is increasing.